Just watching the news, did you hear where last night there was some loud sonic boom over the middle Atlantic? It was heard by people in Great Britain and in the United States.
I didn't hear about that.
Yeah, I just was watching it on the news. They think it might have been some new airplane, some secret airplane that created the noise. But interesting. I'm sure the conspiracy theories are out in force.
Yeah.
Okay, so all of these problems on this page are factoring problems, pretty much. 36 is a division problem. So what's the very first thing we should do?
Turn it to multiplication.
Yep. By doing what?
Taking the reciprocal of it. So
multiplying by the reciprocal.
Yeah.
Okay, now let's simplify it. Start with the numbers.
So 8 goes into 8 once.
Hold on, 8 goes into 32.
4 times.
Okay, so the numbers are 4 in the numerator. Now take the very first letter, X.
X.
So what's the result of x cubed divided by, or multiplied by x to the 4th in the denominator?
Would just be x in the denominator.
Yeah. Okay. Now how about y?
Which would be y squared in the denominator.
Yeah. And there's your answer. Now, usually in these kind of problems, they don't want you to ever put up any negative exponents. So this is the way they would want you to write it, like this, instead of like this. It's the same thing, but usually you don't want to put out your negative exponents.
All right.
Okay, are we supposed to do just the circled ones?
Yeah.
Okay, let's have a look at 39. Okay, before I write it all out, we can see we're looking at a quadratic there. That probably can be factored. I can factor a greatest common factor out of the denominator, and I can factor something out of there. So let's start factoring. Instead of me rewriting the whole thing, go ahead and factor that numerator. How does that factor?
Would be.
Let's go through the steps. Let's make sure you remember my steps. So it goes x,
So x
and x. What's the next step?
Is it the same because it's
Yes, the sign.
adding?
In other words, the next step is to figure out the signs. They have to be the same. In order to produce a plus 48, I need the same signs. What are they? Are they both negative or both positive?
Negative.
Okay. And now what's the third step in factoring that?
You find something that's two numbers that multiply together to equal 48.
That also do what?
Add to equal 14.
Okay. 8 and 6. Okay. Now factor the bottom.
So it's just x parentheses x minus 6.
Okay. And then instead of dividing, well, I can go ahead and divide, or I can multiply by the reciprocal and I'm going to factor out a 3 there.
All right.
Okay? And you see why I'm multiplying?
Yeah.
Okay? In other words, in this case, multiplying by the reciprocal is kind of the same as just dividing by the regular. Now what can I do? In other words, there's a 1 right there.
Yeah, so can't you cross out x minus 8 and then x minus 8 and then x minus 6 and x minus 6?
So what's my final answer?
1 over 3x.
Correct.
Okay.
40. Factor the top. First of all, first thing I'm going to do is turn it into a multiplication problem. Okay?
All right.
So I'm going to have this times the reciprocal of that. Okay, so let's start with the left numerator.
All right. So
Take whatever you
it'd
can.
be 2x parentheses x minus 6.
Okay. And the bottom left denominator factors.
So x and x minus,
Remember, your second step is to determine both signs.
yeah, so it would be both minuses. And then 6 and 1.
Yeah. And then I'm going to multiply it by factor out something from that.
3. So factor out the 3. X minus 3. Or x minus 1.
Okay.
And 2x.
Okay. And now it's just a question of always crossing what you can cross out, which is almost everything here.
So the answer's just 3.
Uh-huh. Now, before we run out of time, what is this equal to? I don't know if you'll have any like this, but this is the only one that gets hard. In other words, this is as hard as these get. This, what I've drawn, what I've written right here. What is 3 minus x over x minus 3 equal to?
Is it just 1?
Negative 1.
Oh.
And the reason is that I can write 3 minus x like that, and I can write x minus 3 as the negative of 3 minus x. Notice that if I distribute this negative, I have minus 3 plus x, which is this. So whenever you have this situation, you can cancel it out. Every problem we're doing here, we need identicals to cancel out, right?
Yeah.
In other words, we've canceled out x minus 6 with x minus 6, 2x with 2x, x minus 1 with x minus 1. Well, the only time you can cancel out if they're not identical is this situation here, where one is the negative of the other. And the important thing is to remember is that a minus b is always equal to the negative of b minus a, no matter what a and b are.
All right.
And that comes into play on some of the harder problems here. All right, let's see. What do we need? We did 40, is that right?
Yeah.
So 43 need to look at. Okay.
Yeah.
Hold on. All right. So factor that.
So it's x and x, and then one's positive, one's negative. So
now what do I need? I need factors of 27 that do what?
subtract to equal
Yes.
6.
6. And just the number. Forget the sign when you do this process. In other words, we need factors of 27 that subtract, because of that sign right there, to the number 6. Well, that's 9 and 3.
Yeah.
And the bigger factor goes with the sign of the middle term. So the 9's got to go there, the 3's got to go there.
Alright.
And I'm going to multiply it by x plus 5 divided by whatever this factor's in. Or what can you take out of this?
A 3x.
And whenever you're doing these problems, if I came up with x plus 8, I would be looking around to find my mistake. Right?
Yeah.
I mean, you see why? If you're not coming up with linear factors here that can be canceled, most likely you made a mistake in your factoring. Not always, but certainly in this case, I'm looking for an x plus 9, so I expect to find that. And then our final answer is x minus 3, and leave it as factored. I don't know, unless your teacher has specifically requested that you multiply those out. This is a better looking answer than if I were to FOIL those two together and produce a quadratic. And one of the reasons is that I don't know what I might need to do with this answer. Maybe I need to divide it by x minus 3, and now I'm all set to do it. Okay? So that's why you leave answers in factored form rather than taking the step to multiply them back together again.
Alright.
All right, let's see. 46.
Yeah.
All right, so let's factor as we write here. Factor the top left numerator.
So x plus 11. Alright. Then over x minus 2.
Okay, and then I'm going to multiply by 1 over this, so let's factor some stuff out of that.
So factor 3x. So x plus 2. Or,
No, you're right, x plus 2.
yeah.
And that goes in the denominator. In other words, this maybe is a little confusing. Whenever you're dividing by that, the reciprocal of that is that. Okay? And I don't need the 1. Well, let's go ahead and put the 1 there. And times, now let's factor top. Well, the bottom is already factored, x plus 11. What's the top factor into?
X plus 2 and x minus 2.
Uh-huh. Now let's go about canceling. So here's an x minus 2, an x minus 2, an x plus 2, an x plus 2, an x plus 11, an x plus 11. What have I got left? X over, I can cancel out that x with that x. So I don't have any x's in the numerator. I don't have any in the denominator, and I'm left with 1/3.
Right.
Okay, 48. Now, just a second ago, let's go back a step. What is that equal to?
X plus 2 and x minus 2.
Even though it's the same as this, I prefer to memorize it this way.
Alright.
You know why? Because when you get to 48, you've got the sum of cubes. And you need to be able to memorize sum of cubes and difference of cubes. What is x cubed plus 8 factor into?
Isn't it x plus 2?
Now see, the fact that you can't remember whether it's plus or minus in the first term is the reason that I memorize this that way.
Alright.
Because this is difference of perfect squares, and the first term is the same sign as what we're dealing with.
Alright.
If you memorize the difference of cubes and the sum of cubes in a similar manner, well, x minus 8, or x cubed minus 8, I know the first term has to have the same sign. That's why I remember the other way, that way. This is x cubed, opposite sign, that times that, which would be 2x, always like that. What is x cubed plus 8 factor into?
X plus 2, and then x squared. Then is it
always opposite? It's always the opposite of this sign, whether you're dealing with difference of squares, difference of cubes, or sum of cubes.
Alright, so
Okay? If you memorize it this way, then whenever you're doing difference of squares, you're going to start by putting the subtraction first. Because this fits with memorizing the difference and sum of cubes.
yeah.
Okay? All right. So, x cubed factors that way. So we'll start off writing this as this. Okay.
Alright.
And then, let's see, what is that? Let me rewrite it starting from the top here. X plus 2 times x squared minus 2x plus 4. And we're multiplying it by x minus 2 divided by x squared. Now, you might say, well, how come I didn't start right off by factoring this? Whenever you have the sum of perfect cubes and you factored it, the quadratic that results is never factorable without using the quadratic formula. Okay? So when I saw this x squared minus 2x plus 4, I didn't go to work on it because I knew it couldn't be factored. Not to mention the fact that I saw one down here which was going to take out the one that's in my numerator. Now I have to multiply it by what?
X minus 6, and then x minus,
Hold on, let's see. We're doing, yeah, go ahead.
then it's x minus 2, x plus 2.
Yeah. And once again, cancel that with that, that, and that with both of those, and I'm left with x minus 6 as the answer.
Alright.
Okay. Is that all we have on that page?
That's all I had for homework.
Okay.
And if you want to do any more, you can. Not really.
Well, let me see, let me look at them and see if there's any that look interesting. Yeah, let's do 49 since we have a few minutes. We'll do the toughest one on there. Good practice in factoring. Factor that numerator.
So x plus, so it's x plus 10 and x plus 2.
Factor the denominator.
The 2x, 2x minus 3 and 2x plus 3?
Yeah. And see, it'll make it easier to memorize as long as you remember that that first term always has the same sign on it as that does. And the second term always has an opposite sign. And then that works for sum of cubes and difference of cubes. Okay?
Yeah.
And then factor this numerator.
It's, I'm not sure.
Take a greatest common factor out of it.
So x squared is the, 3x squared is the greatest common factor.
Leaving behind
2x minus 3.
Okay. And the bottom.
And it's x, yeah, x squared. And then x plus 10.
Okay. And finally we have this term here at 2x plus 3.
Yeah.
Okay. So now it's just a question of, whoops, of canceling. Let's see, we have a x, there's a 2x minus 3, there's a 2x minus 3, 2x plus 3, 2x plus 3, x squared, x squared. So what do we have in the numerator? 3 times x plus 2 all over 1.
1, yeah.
So now the question is that the proper answer, or should I multiply it out? And that, I don't know what to tell you. I would think this is probably the right answer.
All right.
But I don't think she could mark it wrong if you gave her that as the right answer also. In other words, why should that rule that I was just talking about for factoring stuff be affected by the fact that there's a number there instead of a letter? It's still almost better to have it in factored form than it is to have it multiplied out.
All right.
You might ask your teacher, like, what would she prefer for an answer on this one? 3 times x plus 2 or 3x plus 6?
All right, yeah. I'll ask her, or I'll ask her tomorrow.
Yeah, or ask him, yeah, sorry. Okay, well, I think you got a pretty good idea on how to do all of these. You understand the exponents, how to divide same base, different exponents, which was 36 and 37. Do you have any questions at all on like 37? How you would do 37?
No, it seems, or when I was doing some of them in class.
Yeah, you flip that. Once you flip it, now you just got a handle. And just take it letter by letter. In other words, well, actually take it number by letter by letter. In other words, solve the number part, and then solve the x's, solve the y's, solve the z's. And that's all there is to those. They're pretty straightforward. Kind of surprised we didn't see one like I had given you, where you have like x minus 3 over 3 minus x. Usually they'll throw one of those in there. on some of the harder ones, but maybe not. So just be aware when you come across it what you can do with that. Okay, and incidentally, it's got to be exactly that. In other words, it can't be x minus 2. As long as it's 2 minus x, I can cancel that and make it negative 1. If it's something like x plus 2, can't do anything with that. That's the final answer. In other words, the only time you can do it is if subtraction's going on and the other is just the reverse. In other words, if it was 2 minus x, now that's equal to minus 1. All right. Mitch, I will let you go. I will talk to you Wednesday at 4.
All right.
Okay?
Yep.
Have a good one. Bye-bye.